Scabbers?
He's my rat, sir. He's not really a rat. Well, he was a rat. He was my brother Percy's rat. But then they gave him an owl.
The point is, we know the truth. Please believe us.
I do, Miss Granger. But I'm sorry to say the word of 3 13-year-old wizards will convince few others. A child's voice, however honest and true, is meaningless to those who've forgotten how to listen. Mysterious thing, time. Powerful, and when meddled with, dangerous. Sirius Black is in the topmost cell of the Dark Tower. You know the laws, Miss Granger. You must not be seen. And you would do well, I feel, to return before this last chime. If not, the consequences are too ghastly to discuss. If you succeed tonight, more than one innocent life may be spared. 3 turns should do it, I think. Oh, by the way, when in doubt, I find retracing my steps to be a wise place to begin. Good luck.
What the bloody hell was that all about?
Sorry, Ron, but seeing as you can't walk.
All right. I suspect if everybody knew that they'd get
7:30.
to see this or more of a Harry Potter clip, we would have had the full range of people who signed up for the class turn up. Quick question. How long did it take them to time travel? All right, how long did you think it took Hermione and Harry to travel in time? If you don't catch the puzzle in that, you will in a bit. See you, Jenny. All right. So interesting stuff. Issues with regard to time travel. So why don't we start with a survey? Who thinks time travel is possible? So just a show of hands. All right, a handful, many, sort of. Who thinks it's definitely not possible? All right, a few less. That seems no one's very confident. If you judge confidence by height of hand raising. What we're going to do is clarify the question a bit. And then today I'm going to introduce you to some real troubling difficulties with the very concept of time travel. Difficulties that would suggest that it's, strictly speaking, not possible. And then the next class, we're going to unravel the difficulties in a fairly elegant fashion. But we've got to understand the question we're asking first. All right. So on the surface, we're just asking, is time travel possible? The answer to this is trivial, utterly trivial. On one construal, you're all time travelers, right? You entered the room at a certain point in time. You're going to leave at another point in time. You've traveled in time. But obviously, that's not the question we mean to address when we ask, is time travel possible? We have something more interesting in mind. We have in mind questions about whether or not you could revisit the past, right? So backwards time travel. And we also have in mind a question of whether or not you can move forward at a faster rate than you normally do. Right? We're all forward-moving time travelers. But we want to know if you could go back or forward more quickly. It's not the only aspect of the question we need to unravel. There's a further aspect of the question. We'll clarify it by asking a few other questions. All right. So, can you speak Finnish fluently? I've not yet had a Finnish speaker in a class. If you're like me, the answer is no, you can't. It's not possible for you. Can we give people a vaccine that would prevent them from getting the Zika virus? Again, the answer is no, that's not possible. Right? We don't have that ability. Can a human being throw a rock into outer space? All right. No, this also isn't possible. Could you form a geometrical figure on a Euclidean plane that's simultaneously a square and a circle? All right. The answer is, of course, no. So here we have a series of possibility questions, right? Just like we asked a possibility question with regard to time travel, here are some other possibility questions. But you should detect a kind of difference in these possibility questions. One is true. One's a question. The answer to it is that you can't speak Finnish fluently. But of course, you could change that, right? You could acquire the ability through some study. Similarly with two, the answer is no. We can't vaccinate people against Zika. We don't have that level of technology yet. But we have good reason to think that we might well be able to if our countries dedicate enough money to researching it. So strictly speaking, all of these are false when you answer them positively. But there's also a sense in which they're true when answered positively. All right, so how does this make any sense at all? All right. We distinguish different kinds of possibility. Okay. And we just give labels to them to keep things straight. So when we ask about whether or not you could speak Finnish, when we ask about whether or not you could design a microwave, when we ask whether or not you're able to believe there's a pink elephant in the room, often we're asking a question about what you're psychologically capable of, right? What's logically possible for you, given facts about your psychology. Right? When you take facts about your psychology and group them together, there's going to be a certain range of things you're able to do and also a certain range of things you're not able to do. Right, these are all things you can't do. Speak Turkish fluently, unless you can, in which case we'll just change the example. Similarly, there's what we call technological possibility, what we can do given our current level of technology. It wasn't always true that human beings could move faster than 100 miles an hour. Right? But we had a technological advance with the car, and now human beings can. Certain things are technologically possible, certain things are technologically impossible, like vaccinating people against Zika. All right. These aren't the only kinds of possibility. We've got another one that's of interest, what we call physical impossibility or physical possibility. This has to do with what's possible given the laws of nature. Now, the laws of nature, they specify principles or rules or norms, if you will, for the behavior of physical reality. Right? There's a reason every time you kick a normal, healthy human being in the shins, they experience pain. There's a reason every time you drop a pencil, it goes down and not up. There's a reason why getting hit by a fast-moving vehicle leads to death often. There's all sorts of regularities we're well aware of in the world. And what explains these regularities is laws or principles, rules for how the physical world behaves. And when you take the rules, the laws, the principles for how the physical world behaves, there's going to be certain things that are not possible and other things that are. Right? It's possible for you now to look forward. Right? You're doing it. That's consistent with the laws of nature. But certain things aren't possible. You can't, with the bare strength of your arm, hurl a rock into outer space. Right? You can't generate enough force. The human body can't do it. You can't bring it about that water freezes at 100 degrees centigrade. Celsius. The laws that govern water just don't permit it. Now, I'm talking about laws of nature, and you might be asking, well, what exactly are those laws? Well, you got to go to a different department if you want to learn about the laws of nature. You got to go to the physics department. You got to go to the chemistry department. You got to study the sciences. But you don't have to study the sciences to observe the fact that there are laws that govern physical reality. And again, this isn't the question we're asking when we're asking about the possibility of time travel. When we're asking about the possibility of time travel, we're asking about the logical possibility. Right? This is a question we're interested in as philosophers. This is the question that philosophers are equipped to address. And the boundaries of logical possibility have to do with, well, the laws of logic. So here's some laws of logic. These aren't all of them, but they're enough to get going. So first off, we have the law of non-contradiction. Right? This says that there are no true contradictory statements. Right? Contradictories are statements like this. There's a chair in the room, and it's false that there's a chair in the room. Right? That's a contradiction. You're happy, and it's also false that you're happy. That's a contradiction. We'll talk more about principles of logic in the Logic Week. But for now, just notice that, first off, well, actually, we'll just put off the discussion of laws of logic entirely until the week where we discuss logic. For now, just observe that it is a law, a presumed law of logic, that there are no true contradictory statements. Here's another principle that's central in thinking about what's logically possible. We call it Leibniz's law. It says that if two objects are identical, then everything true of one is true of the other. Okay? So think Clark Kent and Superman. If they're really the same person, if they're strictly speaking identical, there's nothing true of one that's not true of the other. So if Clark Kent has size 12 US feet, then so does Superman. If Clark Kent needs glasses to see, then so does Superman. If Clark Kent can't fly, then neither can Superman. Right? If they're identical, then everything true of one is true of the other. All right. What we're going to see is that all the logical problems involving time travel are problems that emerge in relation to these two principles. At least all the problems we're going to discuss. Okay. All right, so on to the question, right? So loosely, our question is it possible to time travel? More specifically, our question is it logically possible to travel to the past or to the future at a rate more quickly than we ordinarily do? All right. Any questions about the question? Any questions about the clarification of the question? All right, so we're not asking questions about physics. We're not asking questions about whether scientists could ever design a time machine. We're just wondering, is there any logical inconsistency in the very concept? Okay. Well, here's one reason to think there is. Here's one reason to think that time travel is not possible. This paradox is called the grandfather paradox. It goes like this. You all have fathers, biological fathers. All your biological fathers have fathers. Now, if time travel is possible, you should be able to go to the past and bring about the death of your grandfather before he gave rise to your father. Right? Because if you were to go to the past, say when your grandfather was quite young, suppose you took an axe with you. Well, if you're there and you see grandfather and you've got axe, what's to stop you from killing grandfather? Right. We can suppose your situation's much less malicious. Maybe it's more like this. You accidentally land on grandfather, right? So you don't intend his death. But either way, if time travel is possible, it seems like it should be possible to kill your grandfather before he gives rise to your father and before you come about. But then we have a contradiction, right? We have a violation of the law of non-contradiction. What's the contradiction? Well, it's this. It's true that your father, it's true that your father gave rise to your, It's true that your grandfather gave rise to your father, who gave rise to you. But it's also false that your grandfather gave rise to your father, who gave rise to you. Right? Because if you kill him, then he doesn't give rise to your father. So we have a contradiction. Right? And The law of non-contradiction says there are no true contradictions. So we've got a problem on our hands. Any questions about this paradox? Yeah.
What about if it makes some other realities? Kill your grandpa, you never born now, but it's just a different
Wonderful.
universe, parallel.
Right, so one way to think about time travel is that you're not actually traveling in time, you're traveling elsewhere. You're not revisiting your actual past, you're visiting some parallel universe that resembles the actual universe a lot. Now, this isn't strictly speaking time travel. It's a whole lot like time travel because you're not revisiting your actual past, the past of the actual. It's a bit like growing up and asking your parents if they could take you to Hogwarts and then saying, well, honey, we could take you to Oxford, and a lot of Harry Potter was shot there. Isn't that good enough? I mean, you're not really going to Hogwarts if you go to Oxford. It's just similar. And that's what you're doing when you introduce ideas about parallel universes or alternative timelines. It's not time travel of the sort we're interested in. So it's true that it doesn't generate a contradiction. It's just sort of a change in topic. Any other questions about this paradox? Yeah.
Is it possible that your existence is so essential to your timeline that even if you killed your grandfather, you continue to exist?
So the only way to sort of make really clear sense of that idea is in this alternative timeline scenario. Because if you're thinking about the situation as, there's just the actual history of the world, right? Your existence in the actual history depends on events that preceded you. You would not be here, and you couldn't go back here unless these events were as they are. Right? So you're imagining a situation in which your existence is brought about, but it's also false that your existence is brought about. Right? So people did things to bring you into the world, but it's also not the case that people did anything to bring you into the world. And this isn't conceivable in any robust sense. I mean, we could say the words, right? It's not ungrammatical to talk of contradictions, but we can't actually conceive of them in a robust way. It's like trying to imagine that there's a microphone here on the desk, and it's also false that there's a microphone here on the desk. So there's something that occupies this region of space and also nothing that occupies this region of space. There's something that would resist me, pushing my hand all the way forward, but also nothing that would resist me shoving my hand all the way forward at that region of space. The idea isn't coherent. Right? So that's the worry with this kind of idea, is that you're imagining a state of affairs that is actually not imaginable, it's not conceivable. And again, we'll talk more about logic and non-contradiction in the Logic Week, but that's broadly the concern with that kind of response. All right. So I've written out the argument for you here. I've written out all the arguments in this kind of form. You'll be able to revisit them in your with the slides I post online. And it's just to encourage you to begin thinking about all the arguments you encounter in this course in an explicit fashion. The way to effectively criticize an argument is to first make it as crisp as possible. And the best way of doing that is isolating the core premises and the conclusion and appreciating how the premises are supposed to support the conclusion. That's all going to make more sense when we talk about logic later on. Let's talk more about problems with time travel. There's an identity problem with time travel. Right, so remember Leibniz's law? If two things are identical, then everything true of one is true of the other. Clark Kent and Superman, remember? Now, if time travel is possible, you should be able to revisit your earlier self or go forward and visit your later self. Right, so you visit you. You visit you. Right, like Spock visits Spock. Why is there a problem here? Well, remember, Leibniz's law says if two things are identical, everything true of one is true of the other. But look, there's all sorts of differences, right? One's got nice, tight facial skin. One's wrinkled. One's got thicker eyebrows than the other. One's got a different outfit on than the other. One has steeper ears than the other. Well, maybe I'm just hard to tell. Anyway, you just look at the pictures. You can isolate many, many differences. If you say they're the very same person, if it's really Spock visiting Spock, then it seems you're in a position of having to deny Leibniz's law. Right? We have two things that are identical, but not everything true of one is true of the other. Right? There are differences. All right. So we have a puzzle. Any questions about this puzzle?
Given that, the longest living cell in the human body lives for about 7 years, after 7 years, there's not a single cell in your body that was in you, say, 8 years ago.
Mm-hmm.
I mean, and presumably all of the atoms have changed. Is there any reason to consider you and yourself from 10 years ago as the same thing? If you can look at yourself as a thing.
Yeah, great question. This turns out to be at the heart of the weeks where we discuss questions about personal identity. How can you be the same thing over time? And the question's driven by just these concerns. There are so many differences between you now and your earlier selves and your future selves. So what unites all these parts of you? Right? So we'll get to that question. Yeah, we'll get to that question. And it is a concern. And it is a concern driven in part by Leibniz's law. Good. All right, other problems. Again, I've written this out for you to muse on. We started with a video clip, right? We saw Harry and Hermione time travel. And it took them a bit of time. How much time did it take them? 8 seconds? 5 seconds? No, not too long. Certainly not a minute. Certainly more than a second. So it took them time to travel in time. Why should that worry us? Well, it worries us because we're asking the question about time travel, about going along, in a sense, a path in one direction. But in thinking about time travel taking time, you're asking about traveling a path in one direction while also traveling along a different path in a different direction. And what we want is a way of thinking about this that makes clear sense of this idea, right? Because it's often a part of time travel stories. It's easy to imagine, right? We can imagine someone hopping in a time machine, starting with a very warm cup of coffee, and it getting quite cold by the time they finish their journey. Right? And it seems like what's happened is time's elapsed, coffee's cooled, and they've arrived at their destination in the past. Well, one way of making clear sense of this is to regard time as two-dimensional. Right? To regard time as two-dimensional. And if you regard time as two-dimensional, what you're thinking of in thinking about our ordinary progress through time is as along just 2 dimensions. Right? So the arrow represents us traversing along 2 dimensions at a constant rate. And when the time traveler travels in time, what they're doing is traveling along 1 dimension going forward, right? Because that's the idea of time travel taking time. You're moving forward, right? You start with a warm cup of coffee, you end with a cold cup. Time's moved forward in one sense, but also moved in a different direction in another sense, right? Because you're going to the past. So if time travel takes time, this is how we'd represent the progress of the time traveler. Right? They're moving backwards along 1 dimension. Right? So the vertical axis, right? They're moving backwards along that. Right? So they're going to the past. Right? So you see the curved line arcing down. But you also see the curved line moving forward. Right? So they're going forward in time while also going backwards in time. Now, why should this be a puzzle? Why should it be a problem? Well, notice that if you want to travel to a time in your past, a precise time in your past, how are you going to do it? You're not going to be able to do it if traveling in time takes time. Because look, suppose you wanted to go to the past 100 years ago. And suppose the journey takes a bit of time. Well, yeah, you'd be able to get to the past along one dimension, but you wouldn't be able to get to that same moment in the past along the other dimension. Right? So you end up somewhere where you didn't intend to end up. And that's the problem. We want to know if time travel is possible in this sense. Can you get back to a specific moment that occurred in the past? But if time travel takes time, then you can at best only get to one dimension of the past, one temporal dimension, and not the other. So you can't actually revisit the exact moment of time that once occurred. Yeah, Andy.
Alright, so if you wanted to go back to a certain time, wouldn't you take into consideration the amount of time it would take? So, say you wanted to get to August 1916, and then, so there's this that point you want to get to, so it takes how many hours to get to that exact point? So you travel 100 hours before August, sort of, these sort of, yeah.
All right, so I get an inkling of what you're trying to do. You're trying to think of ways of traveling along both dimensions that can help you revisit the past. The only worry is that if time traveling forward always involves forward-moving time travel, right? If the cup of coffee always goes from hot to cold in a sort of forward-moving way, then you're not actually going to get backwards along one dimension. Now, this might be a superficial worry. It might be that we could, just apply our minds to the problem for a bit and find out some function that would get us to an exact moment of the past along both dimensions under certain assumptions. And that's fine. What's going to be really interesting, though, is you don't have to invoke complicated theories of time, like a two-dimensional theory, or functions having to do with moving along both dimensions to solve the problem. All right, so this is what we're going to get to next class. So if you don't think it's a deep worry, that's fine. It's a prima facie worry, though. It's a prima facie worry. All right. Again, I've written it out for you. We could revisit it next time. All right, causal loops paradox. All right, so this paradox has to do with a couple principles. One principle is called the principle of sufficient reason. And it says that every contingent feature of the world has an explanation. Every contingent feature of the world has an explanation. What are contingent features of the world? Contingent features of the world are features of the world that could have been otherwise. Features of the world that could have been otherwise. All right, so your hair color is a contingent feature of the world. You all could have bleached your hair before coming to class today. You all could have shaved your heads before coming to class today. You all could have gotten hair extensions. You could have skipped a lot. Your hair, the state of your hair is a contingent feature of the world. The fact that there's a certain color carpet underneath your feet is a contingent feature of the world. Monash may have put in red carpet. They may have put in green carpet, right? There are all sorts of features of the world that could have been otherwise. Now, the principle of sufficient reason says that every such feature of the world has an explanation. It's not just a brute fact that the world is like it is in its contingent respects. There's a reason your hair is the length it is right now. The reason has to do with when you got your last haircut, how fast your hair grows, considerations like that. Right? There's an explanation. There's an explanation for why there's this particular pattern of carpet underneath your feet. It has to do with whoever was making the design choices and what their preferences were, or what their research showed, if they researched things like carpet and laying it down. But there's an explanation. Right, so the principle of sufficient reason says that every contingent feature of the world has an explanation. Now, there's a constraint on acceptable explanations. And the constraint on acceptable explanations says that there are no correct explanations for contingent features of the world that involve those features of the world. All right, so let me just make that a bit more concrete for you. It's doubtless pretty abstract. This is not an explanation for the length of your hair. Your hair is as long as it is because it is as long as it is. Right, that's false. Your hair is not as long as it is because it's as long as it is. Right? Your hair is as long as it is because of when you got your last haircut and how fast your hair grows. That explains the length of your hair. The length of your hair does not explain the length of your hair. I'll give you some other examples. Suppose you only have $50 in your bank account. Right? Sad times. Suppose I ask you why. Well, you haven't answered my question correctly anyway. If you say, because I have only $50 in my bank account. Right? That's not an explanation for why you have $50 in your bank account. Acceptable explanations involve considerations about your spending habits or your work habits or when your parents like to top it up. These are things that can explain the state of your bank account. But the fact that you have only $50 is not explained by the fact that you have only $50. That's a circular explanation, and the principle of sufficient reason with this constraint says that's not a genuine explanation. All right, so how are we with this? Make sense? Any questions about this particular principle? Okay. Now, why is this a problem for time travel? Well, it seems as if we regard time travel as possible, we're going to be committed to a violation of the no circular explanations constraint. And here's a situation that can help you appreciate this. Suppose this is how time travel occurs in one instance. All right, so somebody comes from the future, and they bring with them design plans for a time machine. Right, so Kima comes from the future to the present and brings plans for how we could build a time machine. Okay? Suppose she hands those plans over to someone named Omar, and now Omar has plans and builds, on the basis of those plans, a time machine. Okay? So plans have come from the future. Those future plans have been used in the construction of a time machine. Now we have to ask a question about how those design plans came into existence. Here's one way those design plans could have come into existence. Reverse engineering. Someone looked at the time machine built by Omar and then drew up the plans on the basis of that time machine. Okay? And then we could just assume that Kima brought those exact plans to the past. All right, so we have a loop. And so here's a way of appreciating the loopy nature of this. Ask this question. How is it that Omar knew how to build a time machine at T2? What explains that? Well, the fact that Kima brought plans, right? T1. Well, what explains that she was able to bring plans back? Well, the fact that there was a time machine and she had plans to bring back in the time machine with. Well, where did she get the plans from? Well, they were reverse engineered on the basis of the time machine that Omar built. Right? So the events at T2 partially explain the events at T2. That's like saying your hair color is the length that it is because your hair color is, the length of your hair is as it is because your hair is that length. Right? That's a circular explanation. We regard circular explanations as bad. And now it seems as if regarding time travel as possible is committing us to a violation of this no circular explanations principle. All right, yeah, questions?
But somebody could just build a time machine off their own brain without plans from the future. If there's going to be a time machine, you don't need plans from the future. You could be the first person to.
Yeah, absolutely. So it's not that every time travel story is going to involve a violation of the principle of sufficient reason. It's just that what happened? We lost our, oh, there we are, we're back. It's just that some time travel stories do. And so if this is a general law, that there is always an explanation for contingent features of the world, and none of those explanations are circular, then there can't be any time travel scenarios in which there are circular explanations. All right? But here we have an instance of one. So we have a violation of the principle. So that's the problem. You're absolutely right. Not every time travel story need involve a violation of these principles. But some do, and that's a problem, because these principles are supposed to be perfectly general. They say what can or cannot happen in all conceivable cases. Yeah. Further questions about this particular paradox? All right. Again, I've written it out for you. Here's another problem. So it's a problem of foreknowledge. If time travel is possible, then you should be able to learn things about the future and act on that knowledge to change the future. Should be able to learn about the future and act on that knowledge to change the future. Right? So you go to the future, you get data on the stock markets, right? And so you can place your bets accordingly, invest accordingly. And so that way, you come out wealthier than you would have otherwise. Well, what's the problem here? Well, the problem is this. If you can get knowledge of the future and act on that knowledge to change the future, then once again, like the grandfather paradox, we've brought about a contradiction. It can't be that the future is one way and that you've also changed it so that it is not that way. That's a contradiction. But if time travel is possible, it sure seems as if you should be able to. I mean, what's to stop you from going to the future, getting information about who's going to win what games, what the stock markets are going to be like, and so forth, coming back to the present, and then acting on that knowledge to your benefit, and so change your actual future? Right? Well, what's to stop you? It seems as if that should be possible. But that puts us in a position where we have to countenance contradictions, right? It has to be such that your future was going to be one way, and now it's not going to be that way. So it is one way, and it is not that way. And so once again, we have a problem with the law of non-contradiction. Now, one response to all of these problems is just to say, well, the general principles are mistaken. Logic is a waste of time, or there are exceptions to the laws. And that's how time travel is possible, right? What time travel teaches us is that the laws are mistaken, that they're somehow corrupt or inaccurate or whatnot. That is one way of responding. That is one way of dissolving difficulties. But it turns out to be a really costly way. And it also turns out, and the cost will be seen in our week on logic, but it also turns out to be an unnecessary way. And so here's what's going to be, I think, absolutely fascinating. David Lewis, in the reading that was assigned to you for this week, very handily disarms all of these objections, showing that these problems are all superficial problems, and that you just have to think a little bit differently about time travel. All right. So here's the task. Do the Lewis reading. Know that this is going to be maybe the most difficult reading you do in the course. So don't be overly discouraged by it. We've also written up some really handy notes in the unit reader to help guide you through many of the points Lewis makes. Okay? And by way of general advice, studying philosophy is sort of like being in a morning fog, right? It's thick. Well, you don't really have morning fog around here. This works much better in North America. But it starts out thick. It's hard to see far in front of you. And as time passes, it thins and things become quite clear. your encounter of Lewis is going to be like a thick fog, and with a bit of time and a lecture and a tutorial, the fog will clear. So before I release you, any questions about any of those paradoxes you'd like to raise before? All right. Well, good luck with the Lewis reading. Look forward to seeing you guys Wednesday, and we'll start to unravel some of these difficult problems.